Here we have to find out the electric field due to uniformly charged shell. Okay, so at first see what is the uniformly charged shell. This one is the uniformly charged shell. Imagine this one is the uniformly charged shell. It has charge uniformly distributed. Okay, so I have written, imagine this is one charge hollow sphere it is, or charged shell. Its radius is r, capital R. This charged shell has radius r. You have to find out electric field at r distance from the center. We have to find out what at r distance is larger than the radius. At r distance, small r distance, which is larger than the radius r, we have to find out the electric field at this point. Okay, so we have to apply. How we can find out this electric field? We have to apply what the Gaussian theorem, and due to the Gaussian theorem we will imagine one Gaussian surface around that distance. What type of Gaussian surface? This Gaussian surface. We have to imagine this Gaussian surface around this point, okay, at r distance from the center. Got it? So we have imagined the Gaussian surface and we will apply the Gauss theorem. Next, so you have imagined the Gaussian surface or shell around r, that is its radius is r. Here this one, okay, having radius r, and to find out the total at this electric field at this distance, we will imagine one small surface at this surface. Okay, one small surface at this total hollow sphere. So imagine one small surface dA at the surface. This one is dA. This surface is dA. As you know, here plus charge exists and its electric field is always from outward, where its electric field is always from outward, towards the outwards. Okay, so as it has electric field towards the outwards, so naturally you can see the direction of electric field and direction of the area vectors are same. Here I have written here. Now see, the dA and E has same direction, that is has 0 degree angle. Both of them has same direction, that is both of them has 0 degree angle in between them. Okay, so the total flux through the sphere will be the integration of EdA. Flux equal to what? Area vector into the field. Total flux equal to what happens? Area vector into field. Okay, so here small area vector is dA and field is E. So E into dA equal to the total flux. Integration, we have to do the integration. So we have done the integration of the closed surface. So E is the constant and EdA has how much angle? 0 degree angle. So we have written what? EdA cos theta, that is equal to Q by epsilon naught from Gauss theorem. EdA equal to Q by epsilon naught. What we have learned, that total flux equal to Q by epsilon naught from the Gauss theorem. So we have written E dot dA, that is equal to Q by epsilon naught. E dot dA means dot product is, so it is cos theta. E dA cos theta equal to Q by epsilon naught. Now E is constant, electric field is constant, so it is outside the integration. So we will integrate the dA, that is Q by epsilon naught, as cos theta equal to 0. So this is 1, so it has become 1. Now dA, integration of dA, what happens integration of dA? 4 pi r square. The total surface of the sphere is 4 pi r square. So E into 4 pi r square equal to Q by epsilon naught. So E equal to Q by 4 pi epsilon naught r square. Okay, that is Q by r square and 1 by 4 pi epsilon naught equal to K. Okay, it is also one type of Coulomb law. So we can prove Coulomb law from this formula also.